triangular distribution below shows the PDF for the continuous random variable x. We want to find the expectation, variance and standard deviation. We can see the base of the triangle is 6. We know the area has to be 1. So a half times 6 times a is equal to 1. 3a equals 1, so a is 1/3. So that might come in useful. And then we've got to work out the equations of these two lines. So if we look at this first one, we can see the height is 1/3, this is 1, and therefore the gradient of this one is 1/3. So y is equal to 1/3 x plus c. It goes through this point here, which of course is 1, 0. So 0 equals 1/3 plus c, means that c is negative 1/3. So that's y equals 1/3 x take away 1/3, or 1/3 x take away 1. So if we're looking at the PDF, we can start off with 1/3 x minus 1 when x is between 1 and 2. Now, let's look at this one here. Clearly 2 across to 7 is 5. Rise divided by run, the gradient of this one is negative 1/15. So if we use y is negative 1/15 x plus a constant, and we know that goes through the point 7, 0. So 0 equals negative 7/15. Put in x equals 7 plus c. C is then 7/15, so y is negative 1/15 x plus 7/15, and we could write that as 1/15, 7 minus x, and that goes from 2 to 7, and then it's 0 otherwise. So we know that expectation of x is the integral of x times f of x. We'll have to do it piecewise here, so it's going to be the integral of 1/3 x minus 1 multiplied by x. So why don't I just write that as x over 3 there. And that goes from 1 up till 2. And then we'll have the integral from 2 to 7 of x over 15, 7 minus x dx. And we'll check when we get the actual answer that it's a sensible answer. But we can do this on the calculator. So we've got integral from 1 to 2 of x over 3, x minus 1, that's dx, and then we're adding that to the integral. This integral is going from 2 to 7, and that will be x over 15 and 7 minus x dx. Gives us 10 over 3, or 3 1/3, it's somewhere in the middle. So that one's 10 over 3. Now we know how to get at var x. That's the expectation of x squared, take away the mean squared, expectation of x squared, all we need to do is go in here and change these to squareds. We've seen all this sort of process before. If you're not sure about it, go back and look. And that's 77 over 6. And so that was the expectation of x squared. We need to take away 10 over 3 squared. So that take away 10 over 3, square that one, it's 31 over 18, and then s dx would be the square root of that. Which is root 62 over 6. We could have these as decimals things as well, but it doesn't really matter. The continuous random variable y is defined as y is 3x plus 4. So to find expectation of y, we know that that's going to be 3 times the expectation of x, add 4. So we can calculate that. So that is going to be 3 multiplied by 10 over 3. Could do that in my head. I don't know why I've used the calculator. Never mind. We're there now. Add 4. Gives us 14. Then var y, so the multiplier is 3, is going to be 3 squared times 31 over 18. So I've got 9 multiplied by 31 over 18. That gives us 31 over 2. And then s dy, well, we could get that from the square root of this, or by just doing 3 times root 62 over 6, which would be root 62 over 2. Actually, just square root that one, shall we, just to make sure. Doing it 2 different ways, and there we go. It does work.